let's look at number 2. The first thing that you have to do is figure out which substitution you're going to make. Remember, you have 3 of them. U equals a secant of theta. That happens if you have a variable minus a number. U equals a sine theta. That happens if you have a number minus a variable. And then U equals a tangent of theta, and that happens if you have a plus sign. Well, I look at number 2, and I have a number minus a variable. Since I have a number minus a variable, I know that the substitution I'm going to use is U equals a sine theta. Now I have to figure out what is U and what is a. A squared is 1, therefore a is equal to 1. U squared is 4x squared, therefore u is equal to 2x. That means that 2x is equal to 1. Well, I don't really need to write the 1, so we're just going to say that 2x is equal to the sine of theta. Now I need to get this whole entire integrand, the indefinite integral of the square root of 1 minus 4x squared dx, out of x's and into thetas. Well, let's go ahead and find dx first. I find dx by finding the derivative of this guy. Well, what's the derivative of 2x equals the sine of x? Well, the derivative of 2x is 2 dx, and the derivative of the sine is the cosine of theta d theta. Well, I don't have a 2 dx, I just have a dx. I divide by 2, and dx is going to equal 1/2 cosine of theta d theta. Thus far, I can rewrite this part here as 1/2, and we know that 1/2 we can factor out of the integral, and this guy will just be cosine of theta d theta. Now what I need to do is make the triangle so I can figure out how to get rid of this guy right here, the square root of 1 minus 4x squared. I make the triangle based on the substitution that I used. So I know that 2x is equal to the sine of theta. If this is my triangle and this is theta, sine is going to equal opposite over hypotenuse. So I don't have a denominator, but remember that denominator is always a 1. And then the missing side is going to be that square root of 1 minus 4x squared, the square root left in the integrand. Now, sine, which is the sub, has a Pythagorean identity that relates to which trig function? Cosine, which means I need to figure out from this triangle what is the cosine of theta. Coming over here, the cosine of theta is adjacent, which is that square root of 1 minus 4x squared over hypotenuse over 1. Well, I don't need to write it over 1. So I know that the cosine of theta is equal to the square root of 1 minus 4x squared. So instead of writing this guy here, I write cosine of theta. My integral became 1/2 times cosine of theta times cosine of theta d theta. Well, we know that that's just cosine squared theta. How do I integrate cosine squared theta? I have to use the power reduction formula that we learned in section 8.3. The power reduction formula said if you have cosine squared theta, you would use 1 plus the cosine of 2 theta all over 2. So instead of cosine squared, I write 1 plus the cosine of 2 theta all over 2 d theta. The all over 2 is a constant multiplier, so we factor it out of our integral. So we're just looking at 1/4 the integral of 1 plus the cosine of 2 theta d theta. Well, that's something that I can integrate. The integral of 1 is theta. The integral of the cosine of 2 theta, remember, the coefficient of theta is 2, so we multiply by the reciprocal of that coefficient, 1/2, and then the integral of the cosine of theta is sine. Now the problem with this is that we have 2 theta, but our triangle is for theta, not 2 theta. So we have to use sine's double angle to rewrite sine of 2 theta. Recall from section 8.3 that the sine of 2 theta is equal to 2 sine theta cosine theta. So before I do anything else, I'm going to rewrite my sine of 2 theta with its double angle identity of 2 sine theta cosine theta. Now I'm going to distribute. Notice that this 1/2 and this 2 will cancel right there. If I distribute, I have 1/4 theta plus 1/4 sine of theta cosine of theta plus c. Moving us over here to the right-hand side, the last and final step is going to be to get out of thetas and go back into x's. Well, sine of theta is pretty easy to do from the triangle, so is cosine of theta. The question is, how do I find theta? Well, to find theta, you go back to your original sub. The original substitution is 2x is equal to the sine of theta. Now solve for theta. Well, how do I solve for theta? Well, I'd have to get rid of the sine, so I have to take the inverse sine of both sides. So the inverse sine of 2x is going to equal the inverse sine of the sine of theta. Well, these opposite operations cancel, and then we know that the inverse sine of 2x is going to equal theta. Now we can use that to finalize our answer. So in the end, we have 1/4. Instead of theta, I'm going to write inverse sine of 2x. And then plus 1/4, going back to the triangle, the sine of theta is opposite over hypotenuse, or we found it right here, 2x. And then the cosine of theta is adjacent over hypotenuse, or we found it right here. So we're looking at the square root of 1 minus 4x squared. Let's finally distribute this, and we end up with 1/4 times the inverse sine of 2x. And here my 1/4 and 2 will reduce, and I have 1/2 x square roots of 1 minus 4x squared plus c. What about number 3? The first thing you have to do is identify what is your substitution. Well, I am looking at a number minus a variable. Since it's a number minus a variable, I know that I need to use u equals a sine theta. In this case, my a squared is 16, so my a is going to equal 4. My u squared is x squared, so my u is going to equal x. That means that the substitution I'm using is x is equal to 4 times the sine of theta. Now I'm going to have to rewrite this whole entire integral. Instead of as an integral in x's, an integral in thetas. If I start off here, 4 is just 4, I leave it alone. I'm going to have to get rid of this x squared. Well, if x is equal to 4 sine theta, I know that x squared would equal, well, if I'm squaring that, that's 16 sine squared theta. So here I'll write 16 sine squared theta. I know that this I always use a triangle for, so I'm going to do that in 1 second. And that for the other piece right here, I always just take the derivative. So if I go back to this guy and I take the derivative, what is the derivative of x? Dx. What is the derivative of 4 sine theta? 4 cosine theta d theta. Here I write 4 cosine theta d theta because my dx is 4 cosine theta d theta. Now let's make that triangle. Well, if x is equal to 4 sine theta, solving for sine, I know that x over 4 is equal to the sine of theta. If I come over here and I make the triangle, if this is theta, I know that the opposite side is x, the hypotenuse is 4, and then the Pythagorean identity tells me that the missing side here is the square root of 16 minus x squared. Then determine which trig function is in the Pythagorean identity with sine. It's cosine. So what is the cosine of theta? Look at the triangle. It's going to be adjacent, the square root of 16 minus x squared over hypotenuse over 4. Solving for that square root of 16 minus x squared, because that's what I'm trying to get rid of over here, we end up with 4 cosine of theta is equal to the square root of 16 minus x squared. This guy right here, the square root of 16 minus x squared becomes 4 cosine of theta. Now it's time to clean this up. Well, notice that I have a cosine of theta in the denominator and a cosine of theta in the numerator. I'm going to get rid of those. And then I have 4 times 4, which is 16 in the numerator, and then that 16 in the denominator cancel. What am I left with? Well, I still have this 4, so I'm going to keep that 4 and factor it out of my integral, and it's going to stay in that denominator. The numerator doesn't really have anything left, so I'm going to have a 1 there. I still have sine squared in the denominator, and that's sine squared, and then d theta. So I need to integrate 1 over 4 times the integral of 1 divided by sine squared theta d theta. Well, how do I do that? Well, I just have to remember that 1 over sine squared is actually cosecant squared. Why is converting it to cosecant squared of theta helpful? Because cosecant squared of theta is basic form. We know how to integrate cosecant squared theta. We know that that's going to equal negative cotangent of theta plus c. Distributing, I end up with negative 1/4 times the cotangent of theta plus c. Now get out of thetas and go back into x's. How do I do that? I go to the triangle. What is cotangent? Well, remember SOHCAHTOA. So SOHCAHTOA. If tangent is opposite over adjacent, then cotangent is going to be adjacent over opposite. Coming over to the triangle, if this is theta, the adjacent side is this guy right here, the square root of 16 minus x squared, and then the opposite side is x over x, and then plus c. Finally, distribute here. We have the negative of the square root of 16 minus x squared all over 4x plus c. Let's keep going. Number 4. First, determine what sub you need. I have a plus sign. Since I have a plus sign, I know that my sub is u equals a tangent of theta. Now figure out what is u and what is a. A squared is 1. A is equal to 1. U squared is x squared. U is equal to x. Therefore, this substitution is x is equal to, well, I don't really need to write a 1 for my a, so x is equal to the tangent of theta. Now I'm going to have to get rid of everything in my integral, get out of x's and get into thetas. So I have the indefinite integral here of, well, 9 stays. Now I need to figure out what is x cubed. Well, if x is equal to the tangent of theta, x cubed would equal tangent cubed theta. So for this I write tangent cubed theta. Let's get rid of our dx next. So we need to take the derivative of tangent of theta. Well, the derivative of the tangent of theta dx would equal secant squared theta d theta. So this guy here would be secant squared theta d theta. The last thing I need to do is get rid of the radical. How do I do that? I make the triangle. So if x is equal to the tangent of theta, here's my triangle. We know that tangent is opposite, so that's x over here, over adjacent. There's no denominator, but I know it's a 1. And that the missing side, this hypotenuse, becomes my square root of 1 plus x squared. What trig function is with the Pythagorean identity for tangent? Well, that's going to be the secant. So look at the triangle and tell me, what is the secant of theta? Well, the secant of theta is hypotenuse over opposite. Do I need it over 1? No. But now I know what the square root of 1 plus x squared is. That's going to be the secant of theta. Now that I'm an integral that's just in thetas, I reduce and I try to integrate. The first thing I notice is that one of these secants is going to cancel. 9's a constant multiplier, so we're going to take it out of the integral. And we're just left with tangent cubed theta times the secant of theta d theta. Well, how do I handle this? Well, remember, when tangent is odd and positive, we save a secant tangent and convert everything else into secants. We become a power of the secant. So we have to rewrite this as 9 times the integral of tangent squared theta, secant of theta, tangent of theta d theta. And then remember this tangent squared theta, we use that Pythagorean identity to rewrite it. And it becomes secant squared theta minus 1. And then still times secant of theta, tangent of theta d theta. So all of this is things that we learned in section 8.3 when we were looking at trigonometric integrals. When tangent is odd and positive, we save a secant tangent, convert everything else to secants, and we become a power of the secant. Now that we've done that, we make that substitution. Since I'm already using the letter u, I'm going to use a different variable. Let's use the letter w. If w is equal to the secant of theta, then dw here is going to equal secant of theta tangent of theta d theta. Therefore, this becomes 9 times the integral of, instead of secant squared, I write w squared, still minus 1, and then that secant theta tangent theta d theta is just your dw. Well, this is something you can integrate. Integrating, you get 9 and then w cubed over 3 minus w plus c. Moving over here to the right hand side, we end up with, if I distribute the 9, 3w cubed minus 9w plus c. Now get out of w's and go back into secants. So we're going to write this as 3 and then secant of theta cubed minus 9 secant of theta plus c. Last and final step, get out of secants and go back into x's. Well, what is the secant of theta equal to? Go back to your triangle. Well, the secant of theta, we actually found it over here, was going to be hypotenuse over adjacent. So we can rewrite this as 3 times, and instead of the secant of theta, I write that square root of 1 plus x squared. That gets cubed minus 9 times, again, that square root of 1 plus x squared plus c. Now you can leave your answer like that, but the textbook will rewrite this as, instead of the square root cubed, 1 plus x squared to the 3/2 power. Either answer is correct.